Good morning, class, and welcome back to our subject ESci123, Statics of Rigid Bodies. And last week, we have proceed to a new chapter, which was about the four-system resultants. And on our first lesson, we have talked about the moment of a force, and on the second one, about the Varignon's theorem or the principles of moments. And for this morning, we will now discuss a new topic, and it's still related to moments, but we will now be talking about the moment of a couple. Yes, indeed, when you have a couple, you will also have a moment with each other. So, yung ana lang na, at first, kung gipatuyok-tuyok ka, mag-moment ka, but now, kung nana kay couple, then you also have some moments. Sana all na couple. Charot talaga. Wala ko na ngandoy, char. Our main goal for this lesson is that we will know the concept of a couple. So, unsa man rin ang couple sa statics? Does it still relate sa kanang mga uyab-uyab? Of course not. Why would you expect? And we will learn about that, and we'll also learn how to solve for couple moments. Okay? Let's first define a couple. A couple is defined as duha. Duha ni sila ka-individual. Pero duha ni sila. These are two forces that has the same magnitude. Okay, take note. They have the same magnitude and they are parallel with each other. Okay? So same magnitude, they are parallel with each other. And lastly, they are directed in opposite directions. Okay? So a couple daw is a force that has the same magnitude, they are parallel with each other, and they are moving up in the opposite direction. So I will make one. So I have here one force. Let's call this one F. And we also have another force. And let's call this one F as well. So this F is directed opposite to your other F. So let's just call this one negative F. So as you can see, they have the same magnitude, they are parallel with each other, and they are moving at the opposite direction. This is what you call a couple. If we are going to evaluate this couple, if we are going to sum these forces, what will happen? Kung ato isa mga forces, of course, this is F minus F. So, the sum of the forces of a couple is therefore 0. So, as you can see, kung couple siya, it does not translate, it does not move, it does not change from one position to another. Unlike sa uban nato nga mga situation wherein kung natay force and then unbalanced siya, so there is the tendency nga ang kanang atong body will translate, will change from one position to another. Okay? But in the case of our couples, it does not translate, but it only creates a turning effect. It only creates a movement at a specified direction. Okay? So, example, if you are driving a car, sana all rich, makadrive silang car, kung muanhita sa atong manibela sa atong car, di ba? Kung ganahan mo ituyok ang imong manibela, you have to create a force sa imong right going up and ang imong force sa imong left going down para makatuyok ka sa manibela. Right? So that is what you call a couple. You're creating a force that has the same magnitude but moving upwards and another force that is moving downwards. So they are a couple. And it doesn't create any change in position of your manibela, but it only creates a rotational effect on your manibela. Okay? So therefore, the moment that is produced by a couple is what you call the couple moment. Okay? So this one, couple moment, is that what you call the rotational effect a couple is creating. And take note that a couple moment is a free vector. What does that mean? It does not depend a certain point. Okay? Ang ila lang gidepende kay ang distance sa aning atong couple. Ang ila lang is they only depend on the distance of the couple, of the two forces. How are you going to determine the moment of a couple? So we have a formula here. And okay, let's have this example. Two forces that are parallel, that have the same magnitude, and they are moving at different directions. And for us to be able to determine the moment of a couple, we have this formula. F times D. Okay, take note, it just looks the same sa kaning atong nahibaw-an nga formula about moments. But they are different on some other ways. Why? Because basically, your F is the force of one of the couples. And your D, in this case, di ba, as you can remember on our previous topics, your D is the perpendicular distance from your moment axis to the force, right? But in this case here, your D is now the distance from the other force to the other force. So the distance between the two forces. And again, take note, this is your perpendicular distance. Dili ang kaniga distance, okay, because this is not perpendicular, but only the perpendicular distance between the two forces. Okay? So, yung ana lang. So, again, this is what you call a free vector because it does not depend on a position of your moment axis. Kung na yung moment axis dere, it does not depend on that because your formula is only the force times the distance between the two forces. Okay? Ana lang. Very easy. So, now, what is the direction of a moment of a couple? So, basically, same principle will apply sa atong moment of a force. If this one creates a clockwise na pag-turn, then this one is moving clockwise. And if on the other hand, kung diri ang atong directions, then this will create a counterclockwise na turn. So therefore, it is counterclockwise in that case. Okay? That's how easy it is. Now, sir, question how about we are going to sum multiple couples? Sana all daghag couple.
They ask you how you are, you just have to say that you're fine when you're not really fine.
So may buhaton. Well, basically, if you have multiple couples, all you have to do is to get the resultant moment of that multiple couples. Basically, ang imo lang buhaton is to sum all the moments of the couples. So, basically, ang couple 1 plus couple 2 plus couple 3, blah, 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 and chu. Yan na lang ha. So, kung daghan kag ang mga couple, imo lang buhaton is to sum M1 plus M2 plus M3. Okay? Sige. So, let's have this example. So, as you can see on the figure, we have a multiple couples. We have 1, 2, and 3. And the problem is, we're going to determine the resultant couple moment of the 3 couples. Okay? So, pwede na nimo i-sum di ay ang kanang mga couple. So, what are we going to do? All we have to do is to sum all the moments. And we have to assume a positive direction. So, let's just say that the direction counterclockwise is your positive. And basically, When you sum the moments, you will determine the resultant moment. Okay? And therefore, to solve your resultant moment, let us add all the couples. So, arita una sa atong couple number 1. Okay? Unsa ganito yung formula sa atong moment? Moment of a couple? 300 pounds times distance of the two forces. So, 5 feet. Is this clockwise or counterclockwise? This creates a clockwise nga direction. So, negative. Next, couple number 2, ang 200 pounds. So, sige ato sa ibutang. 200 pounds times the distance of the two couples. Mo ni gihatag, 4 feet. Does this create a clockwise direction or counterclockwise direction? So, padong dito. So, therefore, it creates a clockwise direction still. So, negative gyapon. Last couple. We have another couple. We have our couple number 3, ang kaning 450. So, 450 pounds times the distance, which is 3 feet. And what is the direction na? So, it goes that way. So, therefore, this is clockwise. Counterclockwise. So, therefore, positive. Okay. So, what is the sum? What is our resultant moment? That is just basically equal to negative 950 pound-foot. Sa direction ani? Negative 90 pound-foot directed counterclockwise. But we can just change this one into positive. So, 950 pound-foot rotating clockwise. So, take note. It would be much better if ang inyong final answer should be positive. Okay? Yung lang buhaton is to change the direction. Okay. So, let's have another problem. Let's have this tricking problem. We have here a gear. Okay? And kaning gear, nag-apply nga couple. Okay? At the right and the bottom part of your gear, diha apply ang couple. The question is, we have to determine the magnitude and the direction of our couple moment. This is our couple moment. I-apply siya diri sa atong right and diri sa atong bottom. And how are we going to determine the moment of this couple? Diba, as you can remember, atong moment sa atong couple is force times distance. And basically, that is the distance between the two forces and dapat siya perpendicular distance. So, sige daw. Ato pangitaon kung asa na sila mag-perpendicular. Kaning isa, probably, dira. Kaning isa, dira. So, our goal is to determine this distance. Mao ni ang atong pangitaon nga distance. Summary na ito pag-solve. Or, if you find this one hard, maybe we can think outside the box and make this problem easier. Sige daw. Can you remember unsa tong atong mga principles nga gipang learn on the previous topic? Can you remember Varignon's theorem? Sige daw, let's try to apply Varignon's theorem in this one. So, I have here this gear. Ako lang gi-circle kay kapoy mag-drawing. And this is your x and y axis. And these are our forces. That one and this one. So, instead of determining this distance, how about applying Varignon's theorem in solving this kind of problem? Okay. So, ganitong Varignon's theorem, the moment of a force can be simplified by using their components or the sum of their components. So, let us determine the components of this one. So, this is the components of this bottom force, and this is the component of your top force. So, this is 600 newtons. This also is 600 newtons. And as you can see, this one and this one has the same magnitude, right? And this one and this one also has the same magnitude. So both of these components also are couple. So kani silang duha couple, kani silang duha couple. So aton lang buhaton is to sum the moments of multiple couples. So the same principle. Let us just first assume that the direction of our positive is counterclockwise, and to get the resultant moment of the two couples. So all we have to do is to sum all the moments. So therefore, arita sa kaning usa, kani unsay direction ani niya? Does it create a clockwise or a counterclockwise direction? This one creates a clockwise direction, so therefore this is positive. Okay? So positive, what is the magnitude of these components? Given that this angle here is 30 degrees. So therefore, diretso na ta. We are looking for the x component of our 600 newtons. So this is adjacent over hypotenuse. So therefore, 600 cosine of 30 degrees. So this is your fx. Let's say fx lang. Okay? And what is the distance of these two? We knew that the radius of this one is 0.2. Therefore, this one also is 0.2. Then we can say that the distance of your couple is 0.2 meters. Okay? Easy breezy. Next. Dito sa second nga couple, this one and this one. So, what is the direction of this couple? Will it rotate clockwise or will it rotate counterclockwise? This one, I guess, will rotate clockwise. So, this is negative. And what is the component of this force? So, this is basically your opposite over hypotenuse. Okay? So, this is 600 sine of 30 degrees. And again, what is the distance? This still applies. 0.2 nga distance. So therefore, this is 0.2 meters. And you will arrive to an answer of 43.9 Newton meter. So since this one is already positive, so we can say that this one is rotating counterclockwise. And this one is your final answer. Gets? Diba? It looks hard if we are going to choose this distance. But by applying Varignon's theorem, we have made it a lot easier. So that is how your couple moment works. Understood? So, as a summary of this lesson, we have learned about the moments of a couple. And you also learned what are couples. You also learned the couple moment. And you also learned how to solve for the couple moments of the couples and multiple couples. This one is easy, and I hope that you have understood the lesson clearly. If you have any questions, then don't hesitate to ask me or to comment it on the comment section down below. See you on our next lesson. Bye.